This is for specialist maths that comes out of the Northern Hemisphere 2017 trial exam, exam 2, question number 3. This is 3A. So we've been given a petri dish. The proportion of the dish covered after number of hours is given by this. Express this in partial fractions. So 2 on top of p, 1 minus p is going to equal. Okay, I've got that there. So I've used x instead of p. So interactive transform expand as a partial fraction, where x is my variable. That gives me this. Now I'm not going to have the negative. I'm going to turn that around and say that I have 2 on top of 1 minus p plus 2 on p. And then I've got to hence show. So if I turn this upside down, I've got t equals the integral dp of 2 on p plus 2 on 1 minus p, therefore t equals 2 log base e of p plus minus 2 log base e of 1 minus p. I know that p is between 0 and 1, so that's always positive and that's always positive, so I can drop the modulus signs. The t equals 2 log base e of p on top of 1 minus p plus c. So move the c over, t minus c on 2 equals log base e of p 1 minus p. And that's exactly what they asked me to show. And in part C, or part 3, if half, so at t equals 0, p must equal a half. Find p in terms of t. Okay, so t minus c on 2 must equal log base e of a half on 1 minus a half is log base e of 1, which is 0. So minus c on 2 is 0, therefore c equals 0. So I have t on 2 e equals p 1 minus p, because that's a 0, turn it into an exponential. And if I do x over 1 minus x, I make that equal e to the y divided by 2. Beautiful. Solve for x. I get an expression where p equals e to the t on 2 over 1 plus e to the t on 2, or alternatively, if I divide everything by times everything by e to the minus t on 2 over e to the minus t on 2, I get 1 over e to the minus t on 2 plus 1. That's an expression, or that's an expression, and that's question number 1.